In this question, we are told that the fuel is a mixture made by blending octane and ethanol in a 1:1 mole ratio, and we are asked to calculate how much energy is released when 80 grams of this fuel undergoes complete combustion. This makes the question challenging because we are not given the mass percentage of each fuel. Instead, we are given the mole ratio, so our first task is to convert from a mole-based composition to a mass-based one. Since the fuels are mixed in a 1:1 mole ratio, we begin by calculating the molar mass of each component. Octane has a molar mass of 114 grams per mole, whereas ethanol has a molar mass of 46 grams per mole. If we mix 1 mole of octane with 1 mole of ethanol, the total mass of the blended fuel is going to be 160 grams. Now that we know the total mass of a 1:1 mole mixture, we can now determine the mass fraction or the percentage by mass of each fuel. The percentage by mass of octane in the 80 grams of the blended fuel can be determined by going 114 divided by 160 multiplied by 80, giving us 57 grams of octane present in the 80-gram blended mixture. Whereas ethanol can be found by doing 46 divided by 160 times by 80, giving us 23 grams. Once the mass of each fuel is known, we can now convert these values into moles using their respective molar masses. So what I've done over here is I've divided each of them by their respective molar mass, and now that I know how many moles of octane and ethanol actually underwent combustion, we can then calculate the energy released by multiplying the number of moles of each fuel by their respective molar heat of combustions. The total energy released can then be found by adding the energies combined, giving us a final answer of 3.4 times 10 to the power of 3 kilojoules when corrected to two significant figures.